Okay, so I've got a question here that's a potentially difficult one. I'm getting towards the end of the paper. I'm seeing our recession velocity. Okay, I'm seeing a graph that doesn't look particularly nice. And I'm still using a general principle. Okay, I've got to take reading from a graph, obviously, if they've given me a graph. But let's just see what I can do here. So the first thing, when it's saying recession velocity, that's kind of making me think of redshift. It's giving me the fact that the spectrum of the hydrogen showed the emission line to be here. Okay, so what can I do with this now? Is there a reading I can take from the graph? Well, in the lab, it showed that it should have been this. What's it showing from the graph? It's showing that this is meant to be the ruler, but it's showing that it's 654. So I've got that number over there. I've got something about a recession velocity. Is this leading me towards anything? So I've got something about a wavelength. I've got original wavelength and a new wavelength. I've got something to do with the velocity. Oh yeah, actually, this has reminded me that the formula that I've got to be using is changing velocity over, changing wavelength over wavelength is going to be velocity over the wave speed. So I can just write that formula down. So I've just identified the formula here, but just by looking at what I've got, using the general principle of I need to take readings from the graph, taking that reading over here, even if I didn't know what I was doing, to be fair, I would still make clear that this answer over here. So I'll say the wavelength is equal to 654 nanometers or times 10 to the minus 9 meters, however you want to do it, because even if I can't go further with it, I'm thinking that maybe I'm going to get a mark for like reading the graph or something like that. I'm not sure. Well, from here, can I put the numbers in? I mean, yeah, I can. So the change in wavelength is going to be 656.3, and I'm not going to put in the times 10 to the minus 9 because I know they're going to cancel out. But if you're not sure why, then just always do it. Like, it's not going to hurt you to put them in. Take away the original wavelength, and it's always divided by the original. Sorry, take away the one that I've got, and it's always divided by the original wavelength, which is the one in the lab, so 656.3. I'm looking for V, so that's okay. And then have I got C? Well, this is a EM wave, so it's going to be 3 times 10 to the 8. But what you need to be careful of is that if it's not an EM wave, you can't use 3 times 10 to the 8. So don't just always assume that C is 3 times 10 to the 8. Students do assume that, but C just means wave speed. So it's just whatever the speed of the wave is. Now, if I rearrange this, I should be able to get V is equal to 1.0513 blah 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 times 10 to 6. What's the units here saying? It's in kilometers per second, so that is going to be into two significant figures. 1.1. I was going to give it to 3 nearly. Can I give it to 3? Oh, I can give it to 3 maybe. Yeah, to be fair, I can.